Hello my dear NSEJS aspirants. Let's discuss NSEJS 2023 question paper here. Okay, the first question here is the current produced due to photoelectric effect. What happens it is it increases with increase in the frequency of incident light, or increases with the increase in the intensity of incident radiation, or decreases with the time of irradiation. So tell me, how can we answer this question? See, the basic understanding of photoelectric effect will help you to answer this question easily. See, if this is a metal surface, so where we are using a light source to eject the photoelectrons from this metal surface. Okay, so now if this light source is sufficient enough to eject this electron, then photoelectric effect is observed. Now look at here, if I increase the frequency, there is no effect on the photoelectric effect here. So why? Because I am saying the minimum energy required to remove this electron from this metal surface will be fixed value, right? Even if you increase the frequency after supplying the minimum amount of energy required, there is no change in number of photons ejecting. They just use that extra frequency that is applied here as a kinetic energy of that photoelectron. But if you increase the intensity or the brightness of this incident light, what happens? The number of photons falling on the unit surface area of this metal surface will increases. Therefore, since number of photons is increased as brightness increased, therefore number of photoelectrons also increases. So that increases. So photoelectric effect or current produced, that will be increased with increase in the intensity of incident radiation. Therefore option B will be the very suitable answer for this particular question right now. So current produced will increases with the number of photoelectrons increases right now. So number of photoelectrons ejected will be more when you increase the intensity or the brightness of that incident light. That's it right now. Yeah, let us move forward with one more basic question here. So look at this question. The question says IUPAC name of potassium permanganate. So we follow metal complexes in coordination chemistry, where we will be using IUPAC rules for naming of inorganic compounds. We have KMNO4 potassium permanganate, and we need to give name as per the given 4 options. See, we have first here potassium. Right now, first write the name of cation followed by the name of the metal complex. For example, if I consider this as a metal complex like this, so what is the name of the cationic pair we have? Here it is potassium. Right now, write potassium first. Okay, potassium, and then next name of this anionic pair should be given. First give the name for the ligands in this square bracket here, in this complex here. So we have oxides. How many oxides are there? 4 oxides are there. So you can say tetra oxido, and then next manganese here we have right now. And what is the position? This is in anionic position now. So you should give the name of that particular metal should end with 8. Okay, so if it is manganese, so manganate, like that. So you should write manganate. Okay, so manganate. What is the oxidation state of this particular metal here? It is having +7 oxidation state right now. So write that in this parenthesis bracket like this. Okay, +7, that's it. Okay, since there is the compound is neutral, so name should be ends like this. If it is ionic, you should write here ion. Okay, so where do we have suitable answer here? Potassium tetraoxide, manganese they are saying. No, it should be manganate here. Okay, option D will be the perfect answer for this particular question right now. Yes. So yeah, so manganate here, just look tetraoxido permanganate. No, so just you need to write it as manganate. Okay, so option D will be the perfect answer for this particular question, right? Let us move forward with few more questions. Which are the following properties may have positive value of delta H? So enthalpy will be positive in which of these properties they are saying? See, lattice energy means, what do we mean by lattice energy? The amount of energy released when 1 mole of ionic compound is formed when a cation and when an anion are brought together from an infinity distance to an equilibrium distance, right now. Therefore it results to form a ionic compound, right now. So for NaCl, so cation Na plus and anion Cl minus, when they brought together, so we get a NaCl crystal formation. During this crystal or lattice formation, energy is released. So I can say lattice energy is negative. What is that? It is negative. They are asking the following properties which may have positive enthalpy. Okay, so not the first one. And what about second one? Hydration enthalpy is also negative, right now. So hydration enthalpy means what? When a particular ionic compound, if I say NaCl, when it is placed in the water, so what happens? That water molecules will surround this cation and anion, right now. So during this process also energy is released. So I can say this is also exothermic, which is negative here also. Okay, not A and B. Okay, let's go with other options. Here we have electron gain enthalpy for noble gases. Yes, electron gain enthalpy for noble gases. See, noble gases are already having stable electronic configuration, right? For example, if you take helium gas or neon gas, already they have inert gas configuration like stable, stable fully filled orbitals, like it is having 2s2, and if I say neon, it will be having 2s2, 2p6, right now. So 8 electrons are paired, everything is fully filled. Now addition of electron for this, further addition of electron is highly difficult, right now. Therefore you need to supply high amount of energy in order to add this electron into the noble gases, right now, right. So it means electron gain enthalpy will be positive in the case of noble gases. So this third one is perfectly correct. Next, go for the next one, ionization energy. It means, for example, anything you take, any element you take, so for example chlorine I am taking here, or anything you take, so from this the amount of energy required to remove electron from here. So in order to convert this chlorine to chlorine cation, or you simply take sodium metal, okay, sodium metal atom to sodium cation, like this. So what you are doing, we are removing one electron from these atoms, right now. So during this process what happening, so we are supplying some amount of energy in order to bring that valence electron out, right now. Therefore what is this, we are supplying energy now, so enthalpy is positive in this case, So 3, 4 will be the perfectly correct answer for this particular question. So option B will be a suitable answer here, right? Thank you. And next, move further with one more question here. The ligand with which homoleptic octahedral complex of cobalt plus 3 will be most stable? So what do we mean by homoleptic first? So homoleptic means all the ligands present in that particular complex should be same. Okay, all of them should be same. Okay, something like if I say homoleptic cobalt chloride complex, so it should contains COCl6, something like this, and here some charge, as per that it should contain some charge, then we can consider it as a homoleptic complex. Okay, so right, now look at here the given complex. See, ethylene diamine tetraacetate. See, this complete compound is a ligand, this complete species is a particular ligand, EDTA in the short form we are saying, which is a hexadentate ligand. So EDTA ion, so it is having -4 charge here, okay, which is octahedral, means it should contain -4 charge. Okay, then next, so look at this is a complete one type of ligand. Yeah, I can say this is homoleptic complex only. Next, diene N-aminoethine, so again ethylene diamine. See, 2 types of ligands are there, I can say this is not a homoleptic complex. Okay, so here we have ethane 1,2 diamine, so this is homoleptic diene, and ammonia can also form homoleptic, 6 ammonia molecules are ligands I can take, and it gives us the one particular octahedral complex. But you know, out of this all this, I can say first option will be more stable, because the ring formation, like chelation formation, will be more effective. All of them are having 5-membered ring, okay, which is highly stable. Therefore the first complex will be highly stable one here, and here ammonia will also form, but we have only open chain structure with octahedral geometry having D3 D2 sp3 hybridization in this case. Okay, inner orbital complex. Okay, yeah. So next, here we have we have one more a simple question here. Look at this. Aluminium trioxide. Aluminium trioxide means Al2O3 here. You take Al2O3, calcium oxide, CaO you can take, and arsenic pentoxide, As2O5, like this. Okay, so now what is the nature of this compound? See, Al2O3 is amphoteric, right? Yes, this is amphoteric. And next, CaO is basic oxide, right? So this is basic oxide, because alkali metals and alkaline earth metal oxides are basic in nature. They form basic compounds. Upon hydrolysis, you will get respective hydroxides like sodium oxide upon hydrolysis gives sodium hydroxide. Calcium oxide upon hydrolysis gives calcium hydroxide, like CaOH twice, like that. Okay, and arsenic, which is in maximum oxidation state, +5 oxidation state now. Okay, upon hydrolysis gives oxy acid. So I can say this is acidic oxide. Okay, yeah. So based on this, arsenic pentoxide 3P. Okay, so 3P I can say, and aluminium trioxide 1R and 2Q. So yeah. So based on this 1R 2P 3Q. So fourth option will be perfect answer, yes. So guys, these are the simple questions I have collected here, okay, in this particular session. And now you can try this question and this question also. I will be solving these questions in the next upcoming sessions. And now look at these. These are the questions which I covered in the previous session. So just give a try and try to answer them in the comment box. If you are really facing difficulty to answer these questions, then just go and watch my previous session that I have made on these particular sessions, where I covered everything clearly regarding these questions. See, this is very important and conceptual question. Just try this question. If you are really facing difficulty to answer, just watch my previous sessions. Okay, so thank you for watching. Stay connected. Thank you.